Hey Ralph, it's been a little while. Wanted to show you what I've been making. This is going to be a multi-part, or rather it's going to be one video, but I've been making a lot of stuff lately. Let's turn the camera around and let you see. I'm going to start off down here in the basement where I have a small army of 3D printers that I've borrowed from work. We've got the MakerBot replicator over here, the Lulzbot TAS 6 and the Ultimaker 2 Plus Extended. These two are the workhorses. This one should be, but unfortunately I have to get it to understand that its nozzle is clean and get Octopi to understand that it can indeed speak HTTP. What I've been making over here are brims for personal protective equipment. Specifically, you have this thing on your head with a face shield on the front. My parents are actually doing the face shield plastic application to this, along with foam and elastic for the back so they'll sit nicely on your head. Then I've also got our Formlabs Form 2 from the department over here, ready to go for the next flexible or tough resin thing that I need to make, and a UV Stratolinker, which is incredibly handy because of the fact that it happens to be 254 nanometers, which is also what you'd need to sterilize a mask or a respirator. And yes, it can do more than 300 millijoules per square centimeter, so yeah, it actually works for sterilization. So another thing that I made was, I had this cart from Target, and I needed a monitor stand, so I happen to have this 4-foot long piece of aluminum extruded rail and a spare Visa mount laying around, so that just got drilled out a little bit so that it would accept the screws, and then put the Visa mount up here in the track and put the monitor on that. It's a little bit heavy, it's a little bit wiggly and unstable, but it will certainly do for now. Right, so over here I have my solar power system. So, got a 50 amp breaker over there, getting 12 volts at up to 400 watts theoretical off of my 4 panels outside, which I think, yeah, you can just see them from here. They're leaning against the fence because we don't really want to have me fall off the roof of the garage there, and yes, it is actually snowing here right now, a little bit. But yeah, so those are on the ground right now, laying up against the fence. Power comes out of here, goes into our MPPT solar charge controller, then comes out from there via the battery lines to the battery breakout. And that's these down here, so they're all, I think they're 18 amp hour 12 volt sealed lead acid batteries, and then I've got my fuse board here, which isn't set up yet, but so it goes. And I've got an old tablet here. This is an old first generation Amazon Kindle Fire tablet, and I've just got that here as a status display for this thing because, believe it or not, it connects via Wi-Fi to this little thing right next to it, which is connected to the COM port on here. And so we'll see that right now I'm drawing 6.29 watts to float charge the batteries, and I've got 3.21 watts normal load right now. Now the other thing that I can do is I can say, computer, turn on solar power 1. And this turns on. This is a stiffening cap, a 2.2 farad capacitor rated for about 18 volts minimum. And what turned on there was this Sonoff multi-relay box, which then turns on this automotive relay that can handle up to 80 amps DC. And that's pulling current from here into this 1000 watt inverter right here. And so the 1000 watt inverter is made so that I can actually put my refrigerator on here. This thing will handle up to 2 kilowatts as a peak, and this will allow me up to 2.2 kilowatts. So the limiting factor is actually my draw. Refrigerators usually draw between 1,000 and 1,200 watts, 1 to 1.2 kilowatts when you first start them up. So the idea is that I can put power into this ProWatt SW box here, which is an AC/inverter switch. I've got power coming out of this outlet right here, and in fact, should have power going to this lamp here. I'm not really certain what the problem is, but anyway, we've got 120 volts AC coming out of here, and this is capable of doing up to 15 amps. So, standard for a US refrigerator. Anyway, that's the whole system. More is going to get wired into it, and also back over here, if we follow this wire up in the ceiling, which looks like beefy speaker wire because that's exactly what it is, then we come on down over here to this Frankensteinian monstrosity, which is just an exercise bike with an AC generator in it and a rectifier, and this little MPPT with a sealed lead acid battery. So whenever I turn on the switch, computer, turn on solar power 4. Computer, turn on solar power 4. Okay, I might have to press the button manually, but I can actually take charge that's accumulated in this battery over here and balance that to the battery load up over this way. So I can actually pedal to create power. Should be fun. It's not incredibly fun because you're just sitting in the basement on a stationary bicycle. But anyway, other than that, we have our little pantry over here, and we've got our aeroponics set up down here. So we're growing lettuce inside right now because it's still too cold to really start up outside, and we've had this going more or less through the winter over here. So it's been nice being able to get fresh greens from the basement. Picked up this lamp about, 10 years ago now when we were living in Ithaca, and still hasn't dropped in power output, which is pretty nice for a T-series bulb lamp. Alright, let me take you upstairs and I'll show you what I've been up to up there. Alright, so up here we have the Ender 3, also printing brims. We got a small collection of them over here. And it's doing pretty well for me. This is the personal printer, so this is the one that I've already had here for some time. Looks like I might need more filament soon. Luckily I've got some on order and it should be here in a day or two. Other than that, things have gotten pushed together. That computer that's glowing down on the bottom is actually running folding at home for the COVID-19 proteome. And yeah, so this thing's up here running on Octopi with a touchscreen. So Octoprint running on a Raspberry Pi with a touchscreen display. So in the last few months I also put together this whole wall of parts, which I actually need to straighten up and complete. Unfortunately, stuff has gotten deposited in front of it, but hey, it works for being able to find stuff at least in the top and on these boxes. Alright, so then I've got this thing, which I've been working on with my buddy Joe, who happens to run a YouTube channel, Joe Malovich. He works on micro hydro systems, and we've just got two different distance gauging devices here. So each one's an optical distance sensor, and we're just going to see what the stage of water is at two different points in his hydro system up at the spring up top of his hill. I'll put a link in the video description to his channel. And then we've got the main electronics bench, which is currently kind of cluttered because I've been working on a lot of stuff on it. And not just electronics either. So let's go through these projects as I see them. So we've got the Coventor control board here. And this is actually a control board for an inexpensive ventilator that I've been working on with some folks at the Medical Device Center at the University of Minnesota. And so it's just an Arduino Nano. Don't have the motor driver board in here yet, but 12 volts in, motor out, I2C ports for display, and also a BME 280 or BMP 180 pressure sensor up here, and then 3-pin for a flow meter. And speaking of flow meters, so the idea is that you'd have one of these pressure sensor boards inside of here with the wires coming out of this little stem. This is a 22 millimeter standard respirator or respiration port. Same on this side, and in between we just have an inexpensive flow sensor, which is giving you a pulse width modulated output. That goes into here, and these two potentiometers you can then adjust. I have another version of this board which is a little bit smaller and doesn't have the onboard buzzer for alarms or anything, because this one's supposed to just be used with a laptop attached to it to either run it in stay state and just get measurements, or to actually do closed loop control but without having display on board. Then we have this thing, which is a 3D printed respirator. This has some of this HEPA filter, which is just the kind that you'd normally see in a humidifier, inside of it, clamped in place by one of the small interior pieces that I have. You can see it from the other side here. And so that's effectively the same, it's around about the same rating as an N95 respirator, and so I've got a few of these. These other three here still have to be done up like this one though, because what I did here was I added silicone caulk to the exterior, and so around the perimeter I have a nice seal when I put this up against my face. Like so. So when I've got this on my face, when I'm inhaling or exhaling, it's only going through the HEPA filter in the middle here. And then I don't have to worry about air coming out around. I don't know if you can understand me, but anyway. The silicone really helps maintain a better seal. I still have to put straps on these, but so it goes. Another fun little thing here, this is a normally open AC current switch hooked up to two AA batteries and a small buzzer, same as you saw before on this control board. The idea with this is that we put one leg of the AC power line into one of those Coventor ventilators, and this will tell us if it's exceeding some threshold load. I can adjust what the threshold load is by adjusting this trim pot right here. And so when it goes critical, when it goes over a certain number of amps, then it switches the red light on and closes the contact inside on the relay and sounds the buzzer, meaning, in other words, that you've got an obstruction in your airway or something else is blocking the flow of air to the patient. I also have, coming to me soon, a normally closed one of these, which will be set up exactly the same, but that one is to tell you when the power has actually come disconnected from the ventilator, so you'll know, hey, we should probably plug this thing back in, or put it on emergency power, etc. Finally, I've also been printing off some of these, which are ISO, I think it's 5365, compliant respiratory fittings. So when you're in the hospital and you're looking at ventilators or any sort of breathing apparatus, they're standardized to a 22 millimeter diameter or ID tube. But the thing is that you also have different size hoses for different applications. You've got the neonatal, you've got the pediatric, and then you've got the adult. And adapting between those series is sometimes something that you don't have the pieces for. So by 3D printing these, I can try and get them through the university hospitals to where they need to go, and they'll have ways of adapting one hose to the next, getting people air. Other than that, there's a few other things I've been working on around here, working on the garden, putting together the solar power system, kind of client-side boxes, the drop boxes for voltage, USB chargers, etc. And I've been keeping myself very, very busy. What have you been up to? Talk to you later. Stay safe.